Hi, my name is Bretta Filestra and I am a PhD candidate in the Neuromuscular Rehabilitation Engineering Laboratory in the Joint Department of Biomedical Engineering between NC State and UNC Chapel Hill. And today I'm going to briefly talk about how we measure and quantify human movement to evaluate different assistive technology in our lab. Our main method of analyzing human movement is through optical motion capture. Optical motion capture utilizes infrared cameras that emit infrared light with reflective markers that will bounce that light back to the cameras. With multiple markers on the body, we can capture full body motion. Let's run through a quick demo to show how our infrared cameras see and track markers. Here you can see 12 cameras arranged in a circle. This is similar to how we have cameras set up in our lab space. Why do we have 12 cameras? What is the minimum number of cameras needed to see a marker? Let's start with just one camera. If one camera is used, we can locate the marker in a flat plane. However, we are unable to determine how far away that marker is from the camera. So let's add in a second camera. In this case, the two cameras are directly across from one another. In this case, we are still unable to determine the depth information, how far away the marker is from each camera. But if we have two cameras that are on an angle to one another, we can find where they intersect and locate the marker. And better yet, if we add in a third camera, we have a better chance of always seeing and tracking the marker in 3D space. So why does our lab use 12 cameras? One reason is to reduce the amount of error and to have better tracking accuracy. Additionally, we can have upwards of 40 plus markers on our participants, so more cameras allows us to better track all of those markers. This also helps too in the case of marker occlusion, when say your hands are swinging by your sides while walking and temporarily blocking some of the markers. Let's see motion capture in action. Here you can see markers on a participant as well as what we see when collecting data. Fun fact, this is the same technology used to animate some video games and movies. In our lab, we use motion capture with an instrumented split belt treadmill so that we can measure not only a participant's motion, but also their ground reaction force for each limb to calculate joint level metrics such as power and work, spatiotemporal parameters such as stance time and step length, and balance metrics such as center of mass movement and angular momentum. We can even use visual feedback to display these different parameters back to the user for training purposes. Overall, motion capture is a powerful tool that allows us to evaluate how well our prosthetic devices are assisting the user so that we can continue to improve the mechanical design, electrical control, and human performance.